Okay, this is the second video in the series on balancing what are called solution oxidation reduction reactions or solution redox reactions. And in this video, what we're going to do is balance one of those reactions by what's called the basic method. In the first video, we used what's called the acidic method. Alright, so in this video, we're going to use the basic method to balance this solution redox reaction. Now, for simplicity, I put the steps over here on the right side of my screen. And truthfully, the only difference between balancing these kinds of redox reactions by the acidic method and the basic method is that for the basic method, we follow exactly the same steps as for the acidic. But once we get the reaction completely finished and balanced by the acidic method, then there are two additional steps to succeed in balancing by the basic method, and I'm putting an asterisk next to those steps here. Alright, so what we're going to do is get the equation balanced, and then we're going to add hydroxide to both sides of the equation to cancel out the H plus, and that will cause for there to be the production of H2O that will appear on both sides of the equation, and the final step will be to cancel the H2Os appropriately. So the best way to learn this is just to go ahead and do it, and I've chosen this equation randomly out of a textbook. And I chose it for a couple of reasons. One, it works pretty well with the basic method, but the second thing is that this is an equation that is very difficult to separate into half reactions. And so I picked this because when you cannot separate one of these reactions into half reactions, then what you need to do is just go ahead and work the equation through the steps as a single unit, and so that's what we're going to do here. Now, when you look at the equation, you can see that there's only one reactant, and which happens to be chlorine. And just for a bit of a review, the oxidation number of chlorine is 0, and then when we look at the product side of the reaction, the chloride is -1. To figure out the oxidation number on the Cl that's in the hypochlorite ion, we have to set up an equation. And the way we do that is by letting Cl be the unknown. The oxidation number on the oxygen is -2. And then we set the whole equation equal to the charge on the anion, which is -1. So the Cl here is going to be equal to +1. So the main point here is that the Cl2 in this case is operating as both the oxidizing agent and the reducing agent. So this is both oxidizing agent and the reducing agent as one unit. All right. So let's go ahead and apply the steps. The first thing you need to do is balance the non-O and non-H atoms. And we see that there are 2 Cl's on the left side of the arrow, and there are 2 Cl's over here on the right. So there's nothing that we need to be able to do with that. All right. The next step in the series is to balance the oxygens using H2O. All right. And we have 1 oxygen on the right side of my equation here, so I'm going to go ahead and pull this down. So we're going to add an H2O molecule to the left side of the equation in order to equalize out the oxygens. All right, now we need to deal with the hydrogens, and because we added an H2O over here on the left side, now what we need to do is add hydrogens to the right side of the equation. And we're going to need 2 of them, so I'll go ahead and put 2 H pluses on this side of my equation. Alright, now we need to do the charge balance, and we do that using electrons. So we need to look and determine what the charge is on both sides of my arrows. Well, you see on the left side here that the charge total is 0, and over here on the right side we've got -2 coming from the Cl- and the OCl-, and then we have +2 coming from the two hydrogens. So the net on the right side of my arrow is also 0, so we don't have to do anything with the electrons. So now, where we are, normally at this point we would have to sum two equations together, but since we handled this one as a single unit, we don't have to worry about that step. So now we're down here at step number 6, and in the basic method for balancing solution oxidation reduction reactions, what we need to do now is add hydroxide to both sides, and we determine how much OH- we're going to add by how much H+ needs to be canceled. So we're going to add 2 OH- to each side of this equation. We see on the right side here then that I'm going to change the color of this, so it's going to be 2 H+ plus 2 OH-. So hopefully you recognize that the combination of these two things here is going to equal 2 waters. So I'm going to go ahead and rewrite my equation now. So it's going to be 2 OH- plus 2 OH- plus H2O plus Cl2, and that is converted to Cl- plus OCl- plus 2 H2Os. So now we're down here at step number 7, and what we need to do here is make sure that we've appropriately canceled any waters that appear on both sides of the equation. So we're going to lose an H2O molecule here, and we're going to lose one of the molecules on this side. So the final balanced equation is going to be 2 OH- plus Cl2 to make Cl- plus OCl- plus H2O. Alright, and just to be on the safe side, you should calculate the charge on both sides of the arrow and make sure it's the same. And you can see here that indeed that's the case. We've got -2 on the left side and -2 over here on the right side. So this equation has been properly balanced by the basic method. Alright, now I think I'm going to close on this video, and I'll do a second example, but I think I'm going to do that second example in an additional video.